All right, so we have been looking at atoms and chemical reactions, and I know that you have worked with counting atoms before. In Activity 16, there was an analysis question where you had to count the number of atoms. At the top of this balancing act, you can see atoms are not created or destroyed during a chemical reaction. Scientists know that there must be the same number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients in front of the chemical formulas in the equation. You cannot add or change subscripts. And I'll show you kind of what that jumbled mess means. If you get lost, there are steps over to the side, step 1, 2, 3, and 4, that will help you. So nothing new. We're going to start out by counting atoms in an equation. And then we're going to try to balance the equation by adding coefficients or numbers in front of the symbols. I'll show you what I mean by this first example. This equation says magnesium plus oxygen equals magnesium oxide. And I can see right here, I'm going to count the number of atoms. Magnesium is all by itself. So because there's no number below it, I know that it just has one atom. And then oxygen here, since there's a 2, it has 2 atoms of oxygen. Then magnesium on this side, it's just 1, and oxygen on this side, it's just 1. So I am going to take and I'm going to show that below, where I have magnesium equals, well, there's 1. And then I have oxygen equals, and there's 2 atoms. Then I'm going to draw a line to go to the other side, and I see magnesium has 1, and oxygen has 1 also. Now, I'm not balanced. My magnesiums are the same on each side of the equation, but my oxygens are not. So I'm going to have to do something to change that. That's where we're going to balance the equation. Since my oxygens are off, I probably should start on the right side to try to make this number right here, the 1, go from 1 to 2, so that way it matches the left side. Here's how I can do that. If I add a coefficient, that's just a number in front of an equation. If I add a coefficient, then I now can change my oxygen from 1 to 2 because I added that coefficient. However, since the magnesium is attached to the oxygen, I also have to distribute the 2 to the magnesium. So the magnesium is now 2 on this side as well. Okay, now that's thrown off this side. Okay, now my oxygens are balanced, but my magnesiums are off. So what I probably should do is add a 2 in front of the magnesium. Then when I distribute that 2, the magnesium changes to 2, just like that. Now I double check. My magnesiums are both at 2 atoms, which is balanced, and my oxygens are both at 2 atoms, which is balanced. So the new equation is 2 magnesiums plus oxygen yields 2 magnesium oxides. Okay, I'm going to do another example down below just so that way you can see. It says try these. I'm going to do calcium oxide, or calcium plus oxygen yields calcium oxide. I'm going to do it the exact same way that I just did the magnesium oxide equation. Okay, first thing I always do is I draw a line to represent the left versus the right side of my equation. Calcium, I have 1. Oxygen, I have 2. Calcium, I have 1. Oxygen, I have 1. Okay, I'm not balanced. My oxygens are off. I'm going to start with the right side. I'm going to add a coefficient of 2. I'm going to distribute that 2 to the calcium to change it to 2, and then to the oxygen to change it to 2. I am now at 1 calcium, 2 calcium, 2 oxygens, 2 oxygens. Not quite done. Need to fix my calciums, so I'm going to add a 2 over on the left side. I distribute that 2. My calcium goes from 1 to 2. So my equation is balanced. 2 calciums, 2 oxygens, and it reads 2 calcium atoms plus oxygen yields 2 calcium oxides. Okay. That is all I'm going to show you, just because I don't want to bore you to death. Hopefully you can grasp the concept of balancing equations with just those two examples. On the back side of this page, submit that for points. All right, good luck. You will have some balancing act practice. I would like for you to only do 1, 3, and 5. Okay, numbers 1, 3, and 5. That's all that I need for you to do. 7 is below 7, there's a challenge. It says this is a tough one. If you would like to attempt that, you're more than welcome if you would like to have a little bit of a challenge. But 1, 3, and 5 is what I am looking for you to do for this assignment. And then